Okay, boys and girls, we have been talking about force and motion. And the other day, I did some demonstrations for force and motion, and those were pretty interesting, weren't they? I demonstrated some things with gravity, some things with inertia. And today, we're going to do some demonstrations, or you're going to do some labs, actually, that have to do with friction. So you're going to be doing some friction labs. So when we do some labs, we have to first work on our little, lab book. So you have a little like lab sheet or a little lab book that you're going to be filling out. And so what I want you to do right now, it's got two sides to it. It's got two sides. It's got like the cover and it's got the inside. Right now we're going to work on the cover. So go to the cover. It says Force and Motion Lab. And we're going to start on the cover before we start to do our lab work. Lab is hands-on. So you're going to be doing some hands-on activities today because we have to do some experimentation. So we're going to be doing a lab experiment today. So what we're going to be doing is we want to do some experiments with friction. And we want to see how friction works. Remember how we drew some pictures with friction and it had a ball rolling on some grass? Well, we're going to be doing an experiment today to see how a toy car is affected by some different types of surfaces. And I have got the toy cars here for you. Here's some toy cars. I have different ones. And you'll get to choose your toy car. And I've got some ramps for you. These are the ramps that the toy car will go down. So all the toy cars go down the toy ramp, or down the ramps. And then I've got different types of surfaces for you. And our surfaces are made of different types of materials. And they'll provide a different type of friction. And remember, friction can slow down or stop something. And so that's what we're going to be concentrating on today. How friction works. Whether friction will slow down or stop our cars. So let's look on this side of our paper. Is everybody on that side? So it says, how does the blank affect the blank a toy car will travel? And so these different things are what we're going to call our surface. So let's fill that word in. How does, that's what we want to figure out today. How does that's already there, and the word we're looking for is surface. Nope. How does the surface affect and this word, maybe you'll help me figure out what word you think a toy car will travel. What do you think our missing word is there? What word do you think is going to go there? What's our word there? Bryson?
Friction.
Not friction. How does the surface affect the blank a toy car will travel? What do you think we're trying to figure out? Olivia?
The speed.
Not necessarily the speed. Something else we're going to try to figure out. Evelyn?
The ramp.
Not the ramp. Lucas?
The motion.
Not the motion. These are all very good guesses. Huh. Yes? I can't hear you. Not the aerodynamics of it. That's a good guess too. Yes?
The movement.
Well, it has to do kind of with the movement of it. Yes?
Force.
Not the force. All these things affect it though. Yes?
The lab.
No. Yes?
Movement.
Not the movement. One more guess, yes?
The roughness.
It's going to be the distance, how far it goes. Affect the distance. We want to see if the surface is going to affect how far our car goes. And that has to do with friction. Because remember, friction is going to slow something down, or it can speed it, it can help speed it up. Now, we are going to have some objects. We're going to have a constant. We're going to have two things that are not going to change in our experiment. And then we're going to have a variable. A variable is something that changes. So we have a variable. Now, look at my supplies here. And here's what is going to be the constant. The constant is you're going to always have the same car, because once you choose your car, you don't change your car. So your car is always going to be the same. So that's going to be constant. No matter what surface you use, your car is the same. So that's a constant. Your car is the same. So is your ramp. Your ramp's always going to be the same, car and ramp. So let's put that down for car and ramp, for constant. So you're always using the same car and the same ramp. That's going to be the same. But the thing that we're going to be changing, boys and girls, that's going to make our experiment so different is going to be what?
The surface.
The surfaces that we're going to be raising our car down, that it's going to be going on, is going to be the surface. So let's write surface, because that's what's going to be different, or surfaces I should say, because we're going to use more than one. You're going to get to choose 3 different surfaces. Okay? Now, here I'm going to show you the surfaces, because you're going to need to know this. Now, I want to show you the surfaces that you're going to get to choose from. You are going to get to choose 3 surfaces, just 3. When you're choosing your 3 surfaces, you are going to want to choose from this category of surfaces. You are going to want to choose one that's got a middle friction, one that's got the most friction, and one that's got the least amount of friction. So you're going to want to, in your mind, decide by just looking at them, just eyeballing them. Just kind of looking at them and thinking to yourself, I think this one has got the most friction of those. This one has got the least amount of friction, and one that has got the middle amount of friction. One that's kind of in the middle of the other 2. So I'm going to show you what I have for you to choose from. Okay? Now these are the things you can choose from. You can use foil. It's labeled foil. That could be one of your surfaces. Now, of course, when we're using our products or our surfaces, we don't crumble anything up. It comes back to me just as nicely as when I gave it to you. Okay? Foil, that could be one of our surfaces that you decide to raise on. Okay? So foil. Another surface, and this is called, this might look familiar to some of, particularly the girls. This is called tulle, T-U-L-L-E. They use it in, what do they use this in, girls? Yes?
Dresses.
Dresses and tutus are made from this. This is called tulle. What?
I think I've actually seen a girl wear that before.
Yeah, girls wear this. Tutus are made from it. They wear it, and then tights are underneath it sometimes, right? Sometimes it's underneath skirts. So this is tulle. that is another surface. Now this one doesn't have the labels on it, so I wrote the word down because you're going to need to know how to spell the word. Okay? Cool. Now, our next fabric choice, or surface type, is this type of surface. Is called satin. So you could use satin fabric. And the label is on here. So you could use satin fabric. That's another type that you could use for your fabric, for your surface. Satin. That's another type of surface. Okay, so you can use that. Now here is another type of surface. This is a bumpy surface. Bumpy surface. So you could use a bumpy surface. Here's our bumpy surface. Bumpy. So we have bumpy surface. Now this surface you're familiar with. This is plastic bubble wrap. You are not allowed to pop it. Plastic bubble wrap. So you can use the plastic bubble wrap. Yes.
What if it accidentally pops?
It shouldn't pop. Nobody popped it in the last class. Okay? Now we have another, this is called fleece. Fleece. Maybe you've seen this on blankets. Nice, feels good. Fleece fabric, it's got a label on it so you know how to spell it. Fleece. It's nice and flat. So this is another one of our surface choices. And then here we have got craft foam. Craft foam. So this is another one of our surface choices. Okay? Yes.
I like to make things out of craft foam.
Yes, craft foam is very good for making things. Okay. Yes, I had to go and I had to get all these different things for science. And I had to spend a long time cutting it all out. Okay? So, we have that. And then, those are our choices that we're going to use for science today. Now, you'll be able to choose 3 of them. So you're going to want to choose a variety. You're going to want to try to look at them. You're going to think, I want a middle, a most, and a least friction. Now, here's what you're going to do. Now, in your page, in the middle of your page, do you see you have a table? Do you see the table? Is that, it's right here in the middle of your page. It says 1, 2, 3. Do you see 1, 2, 3? It says 1, 2, 3. That is where you write the name of your 3 surfaces. You don't have your 3 surfaces yet. But when we pick our 3 surfaces, so when it is your turn to come up and quickly, now you've seen the 3 surfaces, so in your mind you should kind of know which 3 you want. When you get your 3 surfaces, you are going to write their names in the chart. Okay, you're going to write them in the chart. And then on there you are going to write which one you think is the most. You're going to write these 3 words. You're going to write most friction next to the one you think is the most friction. Then you're going to write least friction next to the one you think is the least friction. This is just your guess, your one you think is the best. And then middle friction, the one in the middle. Okay, what? I can't hear anything you say through your mask. You need to talk louder, buddy. Okay? Start, you can start, pick 1, 3, any 3 you want. Gabe says I got us some good stuff. He is right. Okay, 3 things. Did you get 3 or 2? 2. Oh, good. I'm glad you got the satin. Okay, next person. Rose, go. Okay, so then write their names in your chart and then decide. Most friction, least friction, middle friction. Okay? Choose quickly. Good one. Okay, Bianca. So write your three surfaces. Write your 3 surfaces. So people are picking their surfaces. Okay, next person, go. Go ahead, Hector. And so then I've handed out the ramps. So everybody has a ramp. They're just made of cardstock. Don't bend them though, because I want to be able to use them again next year. Yes. Hmm. This is very exciting. And then I'm going to explain to you exactly how we're going to do it. I'm going to show you. I'm going to model it so you can see how we're going to do it. It's so much fun. My class loved doing it. We still have to finish. We ran out of time. Okay, go ahead, Bryson. Hurry up. We might run out of time too. So remember, you're writing your names of your surfaces. Write them in your chart. Yes?
I like this craft one.
Okay, write it. And then you have to guess the friction. Right, most, least, and middle. And then if we run out of time, which we might. Oh, once you've written that, you need to go get your science book. We're going to need our science book because we need it for our ramps. We're going to need it for our ramps. Okay. Yeah, this is super fun. Okay, there's like plenty of each of those fabrics. I cut a lot of extras. Yeah, you're going to need your science book because you're going to need it. We're going to need it for the ramps. Okay? And then I'm going to come around with the cars. But I wait for the cars because the person who had to wait the longest for the fabric gets first shot at the cars. Wait for the cars. Okay. Car. Okay, perfect. Okay, now everybody's got a car, and I'll get a car too. Oh, they left me with a good choice. I'm gonna take this fancy car myself. And here's what we're going to do. Now we have our cars now. What we have to do is, did everybody fill this part out? Yes.
My little brother, the first thing he does when he wakes up, he goes to grab his cars and trucks.
He loves his cars and trucks. Yes, they're so much fun. So everybody has to write, and then you have to decide what kind of friction. Satin, S-A-T satin fabric. And then you have to write your friction gas. Okay, did everybody write their friction gas? Okay, you have to write your friction gas. Which do you think is going to be most friction, least friction, middle friction, those fabrics? What do you think is going to have the most, least, and middle friction? Okay? Okay, now, does everybody have their science book? Because you're going to need your science book. You're definitely going to need your science book. Now we have to come up with our hypothesis. And a hypothesis is a guess, yes?
My science book is not in my book.
Did you bring it home and not bring it back?
I didn't bring it back.
Then I don't know where it is, buddy. You need to look around for it. Use your math book, then grab a math book off the shelf.
A science book out of the shelf?
Just, yeah, you need like a 2-inch book. We're using it for the height of the book. Okay, so now we have to come up with a hypothesis, what we're testing. So now we have to figure out what we are testing, boys and girls. So, what are we looking for in our test? So this is what we're going to be testing for. So if a toy car travels on a blank surface, and this is the part you're going to fill in because you have different surfaces. It will, if a toy car travels on blank surface, it will go a shorter distance than when it travels on blank. A blank surface has less friction. So this is, you're going to have to look at your materials and you're going to have to figure out which surface it's going to go a shorter distance on. And you're going to have to pick another surface where it's going to go a longer distance. Do you know what I mean, boys and girls? So you're going to have to look at your surfaces. You're going to have to decide which one of these is it going to go the shortest distance on. So look at them and write that in here. Which one is it going to go a shorter distance on? Because that's what we're going to test. We're going to test to see which one it's going to go the shortest distance on. Then when it travels on, and this one is going to be the one where you're going to write where it travels on, where it goes like the farthest. So which of your pieces of surface will go the farthest? And that's where we're going to write this here. Which fabric piece you think it's going to go the farthest? That's the fabric piece we're going to write down there. Are you understanding? So look at your fabric pieces here's where we're gonna write where it's gonna go the shortest. So which of your fabric pieces, where do you think it's gonna go the shortest? Here's the longest. And then, right here, this is where we write what kind of surface has less friction. What kind of surface has less friction? A rough surface or a smooth surface? So which word is gonna go here, rough or smooth? What do you think? Which has less friction? A rough surface or a smooth surface? What word are we gonna put there? Somebody tell me, yes? A rough surface has less friction? A smooth surface. So we definitely are gonna write the word smooth here. But you guys have to write your own things there. Because there definitely is not a right answer there. Okay? Now, I'm going to show you how to do your experiments. So I'm going to grab a book. Okay, you're going to flip over your paper. Flip over your paper. Because on the other side of the paper, it has the test runs on it. Do you see how it has the test runs? Does everyone see where it has the test runs? It's got trial 1, 2, and 3. So it says data collection. Test each surface 3 times. Record data in table. To calculate average, add all 3 and divide by 3. I'll do the dividing. You're going to have to do the trial runs and add them. Is everybody ready? Okay. So, if you guys who are back there want to stand up so you can kind of see, and maybe kind of move a little maybe this way so you can see what I'm doing. On here, what you're going to do is you're going to write your surface name in the table. Do you see the table? And you write your surface name. So I would write craft foam there. Okay? I would write craft foam. And then what I would do, and I'm going to see if I can bend this so it can see it on the floor. Is I'm going to take my ramp and I'm going to put it on the science book. And I'm going to take, you guys can move, I'm going to take my car and I'm going to put it, oh, maybe I should have picked a skinnier car. I'm going to pick a different car. Where did I put the cars? Oh, over here. Pick a different car, not the best car. Okay, I'm going to pick my car and I'm going to put it on my thing, okay? Then I'm going to measure how far it went. So this car went about 16 inches. And then I'm going to write that for trial 1. I'm going to write down 16 inches. Then I have to do trial 2. So then I go and I put it back and I put my car in and I measure it again. And that one went farther. So then I measure it again. So I go, and this time I have to do my ruler. And I'm gonna have to add on to it, okay, boys and girls? So then if I have to add on to my ruler, I add on to my ruler like that. So I add my 39 plus my 29, 21, 39, 49, 59, 60, so then 60 inches. Although I kind of pushed that one and I should have. And then I go to the next one. I do it 3 times. Then I go to my next surface. And I do it 3 times for each surface. Do you have any questions about what you're gonna do? That's what we do. And then we'll go on to the next part when we're all done with this. Is everyone ready? I'll give you all something to measure with. If I don't have enough, you'll have to measure with your rulers. Okie doke? Let's get started, it'll be fun. And then you'll have to do your conclusion, and we'll have to work on our line graphs and bar graphs. Don't start yet, not until I give you your ruler, because you can't measure yet. Move over that way. So you're not right on top of me.
Thank you.
Oh, can you use your ruler? I'm out, unless Mr. is, okay, you have one. Oh, no, wait, I might have one more, I have one more.